Why is that notification?
Right, all of this is going to be captured on YouTube, by the way.
Really?
The talking, not your faces, it's the talking.
Oh, you have the voice, right?
I don't have the, what do you call that mic?
It's in here.
The lapel mic. It only captures sound from one direction. I probably should get that. But, we'll see.
Last time I sang, we went and we looked for the answer. I got 0. You know, because we didn't put the answer in. And I didn't even come up with the answer. But I can say X is this, or X is this, comma this, or you know, and it's maximum, you didn't get required. First thing. Does it know my name? Does it check it? I don't just put anything.
Just like your relative name. That's all. So,
Hey,
would you
okay.
also be connecting it to like
Yep.
Teams?
Yep. I'm just setting up for the audience at home. If there's any.
I don't think anybody's gonna be home because we're not sure if it's gonna get started.
Great. That's actually a good,
Yeah.
good thing to factor in. But I think it's going to work. And I just posted the announcement. So.
Anubhav, we miss you.
Alright, here goes nothing. I probably shouldn't show this part.
I love Humber.
That's okay.
You record?
Sorry?
Nothing.
Okay. What's up? Beautiful. Let's see. Just that part. So this is being live streamed too, by the way. Okay, not your faces, just what goes on there, and my voice too. So let's hope this thing lasts for the entire duration of class. I think I may need an upgrade on my computer because I think it's not going to be able to handle it. It is becoming slow, but it's okay. We're trying this out. One thing I want you to notice is if you go to Blackboard, and if you go to online worksheets along the left, you'll see. Oh, my bad. Hold on, give me a second. There you go. Online worksheets. In the week 9 folder, you will be able to see a worksheet for today. And today, basically, we're going to be starting quadratic equations, and we'll be looking at 3 methods to solve quadratic equations. Okay, so I'm not going to be using the PowerPoint at all. Instead, I'm just going to go through the worksheet and help. I'm going to go through the questions one by one, but you can go through the worksheet at your own pace. So if you finish early, you're welcome to leave early too. I would be more concerned with trying to help anyone who needs more. Right? But please do attempt all the questions because that's the only way you and I would both know that you can do what's in these 3 sections. Is everyone okay with that? Okay. So this here is a worksheet, and let me just hide this part. If you access this on your device at home or here, all you need to do is type in your first name and last name. I'm just going to put in initials for now. R, F. And the reason for the email is just for the form to be able to email you the final answers for each So you can go ahead and submit the form empty if you want, because it'll just email you the final answers right away. But if you want to work through it first and then submit the answers, that's also fine. So there are, like I mentioned, we're looking at quadratics today, quadratic equations, and we'll be looking at the three methods for solving them. But before we even get there, I have something to mention about quadratics. Let's see how well this works. One thing right off the bat that I would mention is quadratic equations. We won't be graphing any quadratic functions, for instance, in this chapter. The main focus is on solving equations of that nature. Now, how many of you can tell me what quadratic equations look like? Okay, that what you just mentioned there is called the general form. Ax squared plus bx plus c equals 0. That's the general form of a quadratic equation. And so if I give you an example like this, would you be okay with identifying A, B, and C? Okay, so what's A in this case? 3, right? B? Okay. And C would be 1. Is everyone okay with this? How to identify A, B, and C in these equations? Yes? Okay. All right, perfect. In that case, let me try one more example. What if, let's call this example 1. In terms of example 2, what if I gave you something like this? Can you identify A, B, and C in the second example? Okay, the answer is yes, we can. But before we can identify A, B, and C, what do you need to do here? Okay, rearrange them and go back to general form. Remember, general form has 0 on one side, and all the terms are on the other side. So, which side do you want to choose in this case? Left, yeah, you can choose left, you can choose right. But let's say we move 4x over to the left side, and let's move the positive 4 over to the left side too. And I believe everybody would be okay with what the equation becomes here. Get x squared. What happens to the 4x? Minus. And minus 4 equals 0. You guys okay in that table, the far table? Matthew? So what's A in that equation? Anyone in that table? Darnell, what do you think? You're welcome to discuss amongst your table mates if you want. Yep, Marjorie has it. So A is always the coefficient of x squared. So what's the number in front of x squared? Yep. The number that you see here, well, you don't really see it, but you can think of it as 1. So A is 1. What's B going to be? Negative 4. And C is negative 4 too. Okay. Any questions so far? Is everybody okay with this? Still pretty easy. All right. In that case, let's move on to the next part of it, which is to solve equations, or quadratic equations to be more specific. By factoring. And for this one, I'll do one of the examples on the board. One of the examples from the form, the worksheet. You see the very first example? Okay. What do you notice about this particular equation?
See.
Let me help guide your thought process here. First question is the circle equation in general form? You're saying no, you're saying yes. Okay, if yes, why? That's not why. I mean, in general form, what you have is 0 on one side,
Yeah,
all
zero,
the other
yeah.
all the other terms on one side.
Yeah.
Right? So as long as all the terms of the quadratic equation are on any one side and 0 is on the other side, this is in general form.
So x is 0.
That's also correct. So first thing to notice, this is already in general form, correct? Second thing to notice, it's missing the b coefficient. So something like this is an example of an incomplete quadratic, and you might come across these in this worksheet and later on as well. It's incomplete because it's missing a term. Now the thing about any incomplete quadratic, it's always easier to solve these kinds of quadratic equations by factoring, always. The other methods would work just fine, but they would just take longer. It's definitely easier to solve this by factoring, and let's take a look at what factoring involves, because it was 3x squared minus 75. Right?
Yeah.
So that was the first question on the worksheet. If you're solving by factoring, I'm sure you've done this before. What do you think the first step is in this case? Divided by. Okay, you could do that. You can divide by 3 completely, or I hope video stream is fine. Yeah, I hope the stream is fine. But there's only one way of knowing. Let me just check, just for a second. Give me a second here. I think it's there. Yep, it's been interrupted. That's okay. It's still recording, I believe. It'll be fine. We can keep going. Does everybody in this room remember what factoring means in algebra? Okay, there are different levels of factoring, there are different kinds of factoring. The most common kind of factoring is, you notice how there are, on the left side, we have two terms, the 3x squared and the 75, well, negative 75. Between those two terms, is there something, do those two terms have a common factor? Is there a number that can go into both? 3, you're right. So you have two choices here. You could either divide throughout by 3, or you can take 3 out of the bracket. Second. Make everything over 25, you say? I think maybe you mean something like this. You can take 3 out of both of those guys, and what's left inside would be x squared and 25. Right? And the way you can check is if you just mentally multiply the 3 into x squared, you should get the previous term in the step above. You multiply 3 with the negative 25, you should get negative 25. So you could check like that you've done this correctly. Or you could just divide throughout by 3. The end result is when you divide by 3 now, you get x squared minus 25 equals 0. What do you do at this stage? You could use difference of squares. That's one option. The easier option is just to do this. Yep, move the negative 25 over to the right side. What does it become? Positive 25. And then when you square root x to isolate x, you're going to get square root plus minus of 25, which we know to be 5. Yep, so plus or minus. So this actually brings me to another question I have for you. How many solutions can you expect when solving quadratics? 2? Always? Sometimes you'll get, you should get 2. Sometimes you'll get 1, you're right. And sometimes you get 0, but talking about real solutions, yes, 0. But when there are 0 real solutions, you end up having complex solutions. And I'm sure you have done complex numbers before. So that's something you could see going forward. Okay? So keep in mind, you may still see complex numbers in the course.
You'll just see it.
Now, if you're okay with everything I've shown so far, let's take a look at the second question. Could you try it yourself and see what the answer is? And you can call me over. I can definitely walk to your desk. I'll just put this down there. So let's look at the second question, which is
So today we are going to cake. So the practical math
So, not 1.14. And you put up because volume round it I should check mine and see what one is it. You didn't need it. Not so sure now, are you? You see, when they give me all this rap about my 6 decimal places, and see why I keep them. Everything I show on my calculator is what I write down. And as long as the last one. So if he's gonna mark it wrong, he's gonna mark it because I'm too accurate. Because I see where in the class, I get a different answer because mine is more. Oh, you're talking about my girl. You don't believe me? I'll show you a picture of me. We're stinky.
Is everyone okay with the first two questions? Yes?
I haven't seen that.
Like I mentioned, you can work at your own pace. This worksheet is already on Blackboard. If you have a phone or a laptop or any other device, just open Blackboard, go to online worksheets in our course, click on week, and this is there, and you can work at your own pace. But if you don't get something, let me know. Should probably clear the screen. I could, yes, but then everybody sees. So. Oh, damn, okay. Well, only you guys saw it, so that's fine. Plus, this isn't my iPad, so you can see by the branding, it has pi on it. It's the math centers. So the answer in the second one should be, I think it's plus or minus 1.94. Did you get that right? You didn't get it? Oh yeah, that's fine. I should know if you went Okay.
So basically, like, how do we do it? Like, I have a 70 car to take on 75, something like that.
Well, first of all, you can notice that it's an incomplete quadratic. Quadratic equations usually have three terms, 3 parts. Ax squared plus bx plus c, right? You notice how it's missing the x term? So whenever it's missing an x term, you can call, or if it's missing any one of those 3 terms, it's an incomplete quadratic. I made a slight mistake, and what happens with incomplete quadratics is that you can use factoring to solve it easily, quickly. Now, in the first example, what you end up doing is isolate. You can isolate the x squared term completely. You can move the negative 75 to the other side, and you can divide by. So you really have to try it on paper, though. Isolate x squared completely, and you find the answer. Now, how many of you would be okay with questions 1 to 3? 4 also, perhaps. Okay. Let's take a look at what 4 looks like. Sorry, number 3, I'd like you to try it yourself. It should be similar to 1 and 2. Because again, do you think it's a complete quadratic or incomplete quadratic? Incomplete, because it doesn't have, if you take a look at number 4, how many, you see how many terms there are on the left side? So number 4 is complete, number 3 is incomplete. So you should be able to solve number 3 the same way as you did. Oh, maybe not. Maybe not. So let's actually look at this one. Number 3 is interesting. Yeah.
If I were to submit my answer, how would I put them in?
The format doesn't matter. You could say -5 and +5. You could say, as long as the actual form may say that the answers are wrong because it's only looking for answers in a certain format. But as long as you, because it's going to email you the final answers, as long as you match your answer with that and you know that you're right, it's not a big problem. It's not greater than you. Just for your reference. I'm going to do number 4 on the screen. Actually, sorry, not number 4, number 3 on the screen. But I'm going to need your input. How do you think we should proceed with number 3? I'll be right. Let's focus on number 3 first. How would you factor this equation? Is there something you can factor between the two terms? X, okay. So when you take x out from the bracket, what's left inside the bracket? Anyone from the other table over there? What's left inside the bracket if I take x from both?
5.
What's the first term?
1.
Not 1. X. And you can always check that you've done this correctly. Multiply the x with the x, you should get x squared. And multiply 5 with the x, you should get 5x. What happens now? Okay. Uh-oh, I lost it all. Unfortunately, this particular app is like that. So x, basically, the part on the left side, what I want you to understand this part as is, it's saying that either this guy equals 0 or the bracket equals 0, because that's the only way a product can turn into 0. Right? When you multiply two things, the only way it can turn into 0 is if one of them or both of them are equal to 0. So from here, as long as you get into what we call factored form, this is the factored form for that equation. As long as you get into factored form, you can go ahead and set both of those factors equal to 0. So one of the values of x is actually 0. The other value would be found by solving this. X becomes -5. Let me know if this is okay. If yes, we can move on. For those of you who are already at a slightly more advanced level, just work ahead of me. Don't wait for me to get there. Just run through all the questions and see if you can do it. Yep, there is a number 6 also. Okay, you got the 5, right? So you square rooted x to get 5. Whenever you square root a number, let's think of the number 25. 25 is 5 times 5, right? But it's also -5 times -5. Right? Two negatives in multiplication become positive. That's why whenever you square root a number, you get two possible numbers.
So in the paper, if I write like, okay, I don't forgot to mention like positive and negative.
Then you're only stating one answer. Yeah, 1 out of 2. So you have to mention both. So you could say x equals 5 and x equals -5. Or you can do this. You could just say x equals plus minus 5.
So this is applicable to all the scales, right? These are applicable to all the scales.
Yeah. Whenever you're finding square root of something, whenever you're finding square root of a number, you would have plus and minus solution. Guys, are you guys okay with that one? Sort of. Anything you want me to go over again? Okay, right. So basically, are you okay with the green part? How we factored it? Okay. What that, like I mentioned, what that part really means is you have. Let me see if I can go over to this. the reasoning behind that comes from this. Let's say you have something like this, A multiplied by B equaling 0. The only way this statement is going to be true, or the only three ways it can be true, is if A equals 0, or if B equals 0, or if, can you think of the last one? Think of it this way. 3 times 0 is what? 0 times 3 is what? And 0 times 0 is still 0. Right? Now the reason why this applies here is because if you look at the equation we had just now, we had x times x plus 5 equaling 0, correct? Now you can think of your x as A, you can think of your x plus 5 as B. They're both being multiplied together. Now if the left side actually equals 0, maybe A equals 0, which means, remember what our A is in this case? It's x. So x could be 0. That's one possible solution. And the other way to think about this is your B equals 0. And what's B in our case? Plus 5. So you would put x plus 5 equal to 0 and solve that for x also. Yeah. So can you find x from there? Yeah. Yeah. Just negative. Just one side. Is that okay now? All right. What was the next question? What was question 4 like? I think it says x squared minus x minus 6 equals 0. Now, if you're wondering about this one, first question to ask, is this a complete or incomplete quadratic? Complete, because it has all three terms, correct?
So that's why I try to do it like the normal quadratic equation, like break down the middle term and
Yeah, that's the factoring method, which is what we're looking at.
and I end up getting it x minus 3.
You have a slight mistake in there. Did you say x minus 3 and x plus 3? That would be slightly wrong. But just wait for the solution here. How many of you know, just a quick show of hands, how many of you know how to sort of factor this out? Okay. What you need to do here is you're looking for two numbers. The product of those two numbers should be this guy. The product of those two numbers should be a negative 6. And the sum of those two numbers should be, what number do you see in front of x? Negative 1. So the sum of those two numbers should be negative 1. Right? Can you think of those two numbers? If not, I would suggest start with the product. Which two numbers give you a product of negative 6?
Negative 2 positive 3 or 3 plus 3.
Okay, so you could have it could be negative 2 multiplied by positive, so negative 3 times positive 2. Or you could use negative 2 times positive 3. Do you agree that these are the only two combinations? Okay, now even though these two sets of numbers agree with the product requirement, which one of those actually agree with the sum requirement? Will negative 2 plus 3 give you negative 1 as a sum? Negative 2 plus 3 is not negative 1. But negative 3 plus 2 is negative 1. So the two numbers that you're looking for are, I'm just going to erase this part here. The numbers you're looking for are negative 3 and negative 3. Oh, sorry, positive 3. Negative 3 and 20. Because the sum is negative 1. The sum that you're looking for is will be, oh right, you said positive 2 and negative 3. Yeah, I heard negative 2 and positive 3. That's fine. You're okay. Now, do you want to see the quick method here? The quick method is as soon as you can think of these two numbers, if you can think of those two numbers that meet this requirement and this requirement, and if you notice, what's the number in front of x squared right over here? 1. So as long as this is called the leading coefficient, so as long as the leading coefficient in the quadratic equation is 1, you can very quickly jump into the factored form. You can just say x, you can have two brackets with x in them equaling 0. The first bracket would be filled with your first number that you thought of, negative 3. The second bracket with positive 2. Darnell, you have a question? I didn't know it from the beginning. So you would always start with the product. It's a good way. It's a good place to start. So think of two numbers that can give you negative 6. You could try negative 6 and 1, or 6 and negative 1. But immediately, do you see, no matter how you add them, you'll never get close to negative 1 as the sum. Because of this guy. Yeah. So the sum corresponds to the coefficient of x. The product corresponds to the last term, the constant. Once you see it in factored form, which is this one here, can you see the values of x, the two values? Yeah. If you set this guy equal to 0, let me do that in a different color. If you set this bracket equal to 0, what value of x do you get? Positive 3, and from here you get x as negative 2. And those are your two solutions in that case. You guys okay? You guys look good? Anthony, right? Are you okay too? Any questions, just ask me. Anyway, there are 3 Anthony's in this class. So, bet you didn't know that. Can I move away from, can I change what's on the screen? I can change it. Okay. Let's go back to the So you know what? In the interest of making the most of the time we have here, I'm going to ask you to try number 5, and number 6 on your own. Number 6 is definitely more of a challenge question. Number 5 is a little less so. But before we move on to the next section, I actually want to make up a question of my own. It's similar to question number 4, which we just looked at. And let me just go back to this guy here. And the question I'm going to make up is, instead of x squared minus x minus 6 equals 0, what if we had I made a very minor change, but it changes a few things. Do you notice the difference between this one and the one before? Okay. the leading coefficient in this equation is now 2. So the way it affects the process is that you're still looking for two numbers. The product of those two numbers is no longer -6. Can you tell me what the product is going to be now?
12.
-12, maybe?
-12.
Yeah, and the product comes by multiplying the leading coefficient with this number. So product should be -12. And what about the sum? Does the sum change? Still -1. It's still coming from here. Does that make sense? That's one key difference. The second key difference is when you do think of those two numbers, you cannot go immediately into factored form. You have to follow the steps if you want to be careful. I'll show you what I mean if you pay attention to the screen. Let's think of getting those two numbers first. Which two numbers satisfy this criteria? These criteria. Product of -12, sum of -1. Okay, -4 and +3. Yeah. Our numbers are -4 and +3. Because when you multiply them, you get -12. When you add them, you get -1. Right? But because we have a 2 in front of our x squared, I cannot do this. I cannot do this. This would be absolutely wrong. Nope. Can't even do that. So instead, what needs to be done is there is one method called trial and error, but I'm not too sure that because a lot of people make mistakes if it's been a while. So instead, what happens is you go back into your original equation. There's 2x squared, and there's a -6, but we end up splitting the middle term. So instead of writing -6, I'm going to use our two numbers we just found. I'm going to write -4x and +3x. You notice I'm not really changing the value at all. I can write -x as the sum of -4x plus 3x. So once you do this, can anyone tell me what happens next? The word factor pops up again. So you need to factor the first two terms and factor the last two terms. Yep, you're right. And factoring, we'll just do regular common factoring. What's common in both of those terms? The first two, 2x. So if I write 2x outside, what's inside the bracket? Yep, you're right. And here's a clue. You need the same bracket to repeat itself. So what should be taken out from the last two guys? Positive or negative? You have to include the sign. Positive, okay. Right. So make sure you include this sign when you're doing this step. What happens now? You can actually go into factored form from here. You notice how this, I'm going to underline it in green. Do you notice how this bracket is being repeated twice? If you take that bracket out, common from both, you get x minus 2 outside, and what's left inside? 2x plus 3, right? And that would be the factored form of the equation. You're just one step away from getting the solution also. What do you get from the first bracket? 2, and the second bracket? Yeah, -3/2. So I don't have space on here, so I'll just write it over here. A different color. Any questions so far, guys? Well, I'm leaving the very last step for you guys. Do you notice how this bracket, the one I'm underlining in green, is in multiplication with the second one? You see it? and their product, the product of the two brackets equals 0. So set each bracket equal to 0 and solve for x. Once you solve for x, you should get the answers in green. I put it up in a box. You should be able to get that. Are you looking ahead? Are you stuck somewhere? Sorry, say it again? Question 5. Oh, right. Oh, right. So you're talking about this one, right? The big one? With the bracket? Yep. Let me just clear this up. I'll be right there.
That was fun. Oh, you did fun.
Yes,
What is it? Oh, there's a 2, there's a 1, 2, 3. X squared minus 8x. X squared minus 8. It's actually plus the 1 on the x squared, which is x squared minus 8x plus 6. Yeah. Completing the square. Minus 8x plus 6. Yeah. It's minus 3. Equal that with 1. I know. I'm starting with. I said part in my. It's on the phone.
Just for a second.
You're laughing at me?
I hit it all. No, no. Okay. That's fine. For question 5, does anyone have the general form of the equation? Anyone else apart from undergrad? Say that again? You have to not factor the opposite of factoring. You have to open up the bracket. Yeah, distribute the x. So okay, hold on. First step, when you multiply the x in here and the 2x in there, what do you get out of that? Yep, x squared. Yep. Yep. 2x squared plus or minus? After 2x squared, yep, it's minus 2x, okay, plus 9, right? Okay. No. See, here's the thing. You want to combine it, but you want your end equation to look like this. And this part is the key, the most important part. You want 0 to be on the right side, or well, or the left side, on one side. So do you notice how you have terms on both sides of the equal sign at the moment? Well, all of them. You need to move everything to one side. So it's up to you. You can move the 2x squared minus 2x plus 9, all of them over to the left side, and then combine like terms. When you do all of those steps, you should be able to get the general form of the equation. And that's what I'm waiting on. Yeah. X squared plus 6x plus 9. You should get something like this. So I won't solve the rest of it. I'm going to leave that up to you for the factoring part. How many of you are okay with factoring? Just a quick show of hands. Right. So, what do you think? Break for 5 minutes or just continue? Finish a little bit early? Which one? Which part sounds good?
Both of them. Finish early.
Finish early, okay. The answer for this one would be this -3? Yeah. There's only one answer here. Where are you? Are you, did you get to the general form? Hey. That's interesting. Give me a second. It seems to have frozen.
I don't know about that, but I know.
Okay, you know what? This thing has frozen for now. Something wrong with it. I wish. Let me just clear this for a second and try to fix this. Let's take a quick 5-minute break or 10-minute break. Computer made the decision for us. Sorry, what's the question?
I end up getting something like this. So.
Now, there's a mistake here. Can I show you?
Yes.
Remember, you want this bracket to be repeated here.
Yeah.
So, what should you take out so that you still get x minus 3 here?
I took out the -3.
Oh yeah, you took out negative. That's actually correct. But let's see if you did this part correctly. -3 times x is -3x.
-3.
But -3 times 3 is not +9.
Yeah, -3. Oh, okay.
That needs to be a negative.
Negative.
And you can always tell that you've done this correctly if you get the same bracket.
Yeah. I always end up getting messed up with the signs.
Right. I may have to. Can I pause it? Yeah.
Is this straight?
Yes. Negative 3 and negative 3. And because of the same exact number, you only have to write it once.
Okay. Oh, so I just write it once? I don't. Okay, thanks.
Welcome.
Here, like, Anthony, you don't have to remember. You don't get a financial. You have to remember there was no formula sheet at all, right? So you get 100 on mathematics, you have to remember all the damn formulas. Yeah, everything. It's about that then in high school. You tell a teacher, he would come and assign a problem, and the first time to finish it, like say, you take the first 5, you'll mark if it's right. It'll give you an initial, right? And we used to collect initials. Who did the mix? So we put up from and do that everybody wrote and wrote. So, and you see this initial was so good. It was like a child.
Okay, I think we are back.
I guess that what you use for the second circle. So, the formula.
Want me to come over?
Completing the square. Okay, you're doing that. I'll do it. Completing the square. Did I sound like you? Yeah.
Does anyone have questions? Hey.
Oh, yeah, that's question. No, no, he's a baby. That is good. Oh, wow. Oh, okay. Oh, yeah, that's right. We said fifth grade. System, our system was different. We go the first one, second one, third one, fourth one, fifth one. Yes. You never wear a uniform too. I used to wear a tie. Oh, no, not really. That's private school, man. That's private school. Yeah, we had blazers too, but that's a special occasion. Oh, okay. But no, just uniform, like khaki. No, no, no. Private school, no money. You like my uniform. normal dresser, and then the blazer and stuff, yeah. And you got your shoes and when you up now, you just khaki and you have a few sets of khaki and you wear them. No, hell no. Boy, that's it. Yeah, you got money. You got money. You got money. You walk the street. Walk home. Yeah. No, boys, go home every day. Walk home. Walk in the room, go home. Oh, that was good. The high school I went to, the girls love the guys, right? So when you have one of the guys, the girls don't finish it out. That's the thing. It was an all-girls school, right? So they used to, speak on that stuff. We used to take off our clothes, right? Because most of the schools were uniform, right? So they couldn't tell which school we were. They didn't have the time. But there was one guy who would be in the room all the time. Yes, sir, Mr. President, we need to like all the way home. But we take off all the time. The moment school is over, we take off all the time. There's one guy in the group, that's a big cheap guy. So the girls don't know that we're from that school. But sometimes it's not true because you don't have to do much work. They come to you, you know. That was right, yeah.
The best of the best.
Yeah. Oh, yeah. Make a job easier. You still have to have doing this. But then you gotta be able to lots of thoughts. I know you just walk the walk.
All right, breaks up. Let's finish this up. Let's do the last part. Oh no, not this again. I trust you guys better, but still, you know, I have to take precautions. So, did it start up yet? No? Yeah. So question 6 is for you to try yourself. We won't look at that for now. But I'm going to go to the next section where we are going to be looking at solving equations by completing the square. Method number 2 out of 3. And how many of you have seen this already or still remember how to do it? Just a quick show of hands. How many of you remember completing the square as a method of solving quadratics? Okay, not anyone. All right, so this should be good. There are 3 questions in total in this section that I've included, but I'm only going to do the first 2, okay? And the reason why you'll see very soon, there is a really small difference in how in the steps for the first 2. And if you can do the first 2, you should be able to do all of them. And let's just go into this and start editing it. X squared minus 8x plus 6. Okay. So completing the square. It's crushing it. Not good. Does anyone have the worksheet open in front of them? Right, do you have the worksheet open in front of you? Yeah. Is that the question?
No, x squared minus 8x.
Minus 8x plus 6. Okay. My app just crashed also. So all right, completing the square. So please pay attention to the screen, especially if you haven't done this in a while. What you end up doing in this question, in this kind of, in this solution, this method, is as long as your leading coefficient is a 1, the first thing you need to do is you need to move your constant term, so that in this case the positive 6, to the other side. Okay, so you're moving away from the general form. You'll get x squared minus 8x on the left side. And what happens to the positive 6? It becomes negative 6. Okay. Everyone okay with the first step? Right. I have to make sure. The next thing to do, and I'm just going to have to, I'll do this in a different color. What's the coefficient of the x term? Negative 8. I'm just going to underline that. For that number, the first step you have to do is coefficient. Okay, what's half of negative 8? Negative 4. Perfect. Number 2, step number 2 is to square from step 1. So when you square negative 4, what number do you get? Yep, 16. And step number 3 is to both sides. So let me know if you have those 3 steps down, because I can just erase them and work out the rest of the problem. Now, because we are adding 16 to both sides, the equation is still balanced. Okay, we're not changing anything drastically. We're just changing the look of the equation. Can I erase the 3 steps? Do you have it? Okay, all right, let's hold on, you said. You must have step 1, at least. Okay, so I'll start with step 1. I'm going to get rid of that. You must have step 2 also. So step 2 goes in. Okay, perfect, thanks. All of it, right? Okay. So the result of adding the 16. What do you get on the right side when you add 16? Just 10? Yep, you're right. 16 minus 6 is 10. On the left side, we're actually going to do what the method is called. We're going to complete the square. I'm sure last semester you must have come across difference of squares and the perfect square trinomial. The perfect square trinomial is what we're going to be doing here. And the way you can make it quickly is you need a bracket. Outside the bracket, there's going to be a square. The exponent is going to be 2. Can you guess what the first term in the bracket is going to be? X, yep. So it's basically, if you want more sort of clues, the first term is going to be square root of that. Square root of x squared will be just x. The last term will be square root of the last term. What's square root of 16? 4. And the sign between the 2 terms is going to be whatever sign you have here. So it's minus. So we just changed a 3-termed expression into a perfect square. X minus 4 squared equals 10. And the reason why we did that is because you notice the square is for the entire bracket. How can you get rid of the square? Square root both sides. Yep. And you get, what do you get on the left side? Just x minus 4. The exponent disappears, and on the right side you get root 10. You're saying, okay, did I miss something? Plus minus, yeah. Always remember to put that in. Plus minus square root of 10. And do you notice how there's only one more step to isolate x completely? Which is to, yeah, move the negative 4, remember it's negative, to the other side. And when you do that, you get the final answer. X equals plus minus square root of 10 plus 4. And the thing is, you can actually leave it in this form, in radical form. You don't have to do anything more than this, unless the question says round to 3 significant digits or something. Unless the question says round, you don't have to change this to decimal. But I hope everyone can change this into decimal form on the calculator, right? Okay. And do you also notice there are two solutions here? Okay. So with that in mind, I'm going to go to the other question. Right, I'm going to need your help again. What was the second question? I think it's just 2x squared.
Plus 4x minus 3.
Okay. Can I change this screen? All right. I'm going to go to the second question in the worksheet. It's 2x squared minus 4x, you said? Plus 3?
No, plus 4x minus 3.
Oh, plus 3. Now the main difference between this equation and the one before is that there's that number over there, the 2. Okay, that's the only difference in the steps also, you'll see very soon. Before we go ahead and do the remaining steps, we have to do one thing, which is to get rid of 2 completely. So what operation can you use to get rid of 2 from x squared? Say it again?
2 minus 3.
No. This is a different method. Yeah. So divide the whole thing by 2. Divide this guy by 2, this guy by 2, this guy by 2, this guy by 2. Divide both sides of the equation by 2, and this way you are going to get x squared. What else do you get? 2x and yeah. And how many of you are tempted to go into decimal form for that number? I'm going to say don't go into decimal form. Leave it as a fraction. You will thank me later. But keep it as a fraction, and on the right side, what's 0 divided by 2? 0. Okay. And now that the number in front of x squared is just a 1, repeat the steps you did for the previous example.